In this video, I want to talk about LCM and GCF and how to calculate them efficiently. LCM stands for least common multiple, GCF stands for greatest common factor. I want to get two things across today. The basic method of how to find these two and a little bit of a trick. Okay, so let's go with 6 and 8. So a lot of you may already think you know this. In school, what they normally have you do is just poke around till you sort of have it. So we want to know how to do this very efficiently today. So 6 and 8, what's the GCF? Well, we could just sort of see that 2 is the highest number that goes into both. So first of all, what is a GCF? It's the greatest common factor, so it's the highest number that goes into each of these numbers. So 4 is too high, 3 is too high, 3 doesn't go into that, right? 2 goes into both, and nothing larger than 2 goes into both. All right, what would be the LCM? The least common multiple. In other words, the first number that both of these numbers go into. So you might say, let's try 16. 16 doesn't work because that's 8 plus 8. Let's try 24. Oh, 24 works. 24 is divisible by both. So that's the least, that's the first number that fits both of these. All right, let's try another one. How about 4 and 8? Here the GCF happens to be 4 and the LCM is 8. I only mention this example to illustrate one point. The GCF and the LCM, they could happen to be one of the numbers. They're not necessarily a different number. Okay, so 4 happens to go into itself and into 8, and there's nothing higher than 4 that goes into both. 8 is the lowest number such that both of these go into that number. All right, so that's some basics. So let's say you want to find the LCM and GCF of these two numbers. Using your prime factorization skills from the previous videos, you should know that this is going to be 2 squared times 3 squared, or 4 times 9. And this will be 2 cubed times 3, or 3 times 8. All right, so rather than trying numbers, like for example, does 2 work? Yes, 2 goes into both of them. Can we beat 2? Let's try 3. 3 works, so 3's better. Let's try 4. 4 goes into both of them. 4 is even better. How about 6? 6 is even better than 3 and 4. And you could keep trying that, but the larger the numbers, the messier that gets. So that's not really a good process of just trying everything in order and seeing if it works. So the basic method will be a very fast way of seeing how do you find these two given their prime factorizations. So I'm assuming you can already find their prime factorizations, and we're just going to be working from here. So to find the greatest common factor, you literally see what do these two things have in common. So they have 2's in common. How many do they have in common? Well, this one has 3 of them, this one has 2, so they only share 2 2's, right? Because this doesn't have 3 2's. So if they were playing a game of chicken, this one lost, this one continued to have more 2's. So the only thing they have in common is 2 2's. Now, they also have 1 3 in common. So that's your GCF. You can also sort of think of it as a minimum of these powers. Okay? So that's what they have in common. So there's your GCF. Now for the LCM, we're going to go the other way. We're going to see, we want it to be the least. So we're going to say, what did these two have between themselves? And we're going to take the maximum. So we're going to say, okay, I see at least 1 2. What's the maximum power? It's a 3. Now, why are we doing this? We need at least 3 2's, because if there's fewer than 3 2's, then our LCM will not fit this number, which has 3 2's. If there's more than 3 2's, then we're not finding the least common multiple anymore. So you don't need any more than 3, but you need at least 3, which is why we're picking 3 2's. And now you see a 3, right? And now what's the maximum? The 2 power is higher than the 1. So your LCM would be that. All right, let's run this on a larger example so you guys can get the hang of it. So let's say you have this messy prime factorization. and your second number is, all right, so for the GCF, let's do that first. We see, what do these two have in common? They have 2's. What's the minimum of the powers? It's a 3. All right, how about the next prime number? They have 3's in common. What's the minimum of these powers? It's a 5. And they have nothing else in common. So that's it. There's your GCF. The LCM. You see, do I see at least a 2 over here? Yes, I do. What's the maximum? 4. So I need at least 4 2's to accommodate this number. Now, do I see any 3's? Yes. They don't both have to have 3's. At least one of them has to have a 3. So what's the maximum power? We choose the 6. Now, any other prime numbers? Yes, we see a 7. And since there are no 7's here, then we just take whatever we have here. And then we take the 11 from there. Technically, we're always taking the maximum. So when we took the 7 squared, this, you could think of it as having a 7, but it's 7 to the 0th power, and anything to the 0th power is 1. So we chose 2 7's over 0 7's over here. But that's getting very technical. Okay, so there's your LCM. So notice, again, to find the GCF, we basically found what prime numbers do they have in common for the bases, which are 2's and 3's, and we took the minimum. We took the 3 instead of the 4, and we took the 5 instead of the 6. For the LCM, we took every prime number we saw to the maximum power between the two that we saw. All right, so that's your basic method for doing these large numbers. Now, if you don't have these, remember, you first want to do the prime factorization tree and get this set up. Then you can apply this method of minimum and maximum. All right, now the slight thing I want to mention is this trick. So let's say you want to find the GCF and LCM of 96 and 100. Now we could break these down, right? So this would be 4 times 24. We could do the whole factor tree. This would be 2 squared times 5 squared. We're not going to even do that because that would be your basic method. What we're going to do is think of it like a frog. So how far is it from 96 to 100? It's 4 units. So that means if you're a frog jumping in 4s and you just landed on 96, if you jump another 4, you should hit 100. That means your greatest common factor cannot be any more than 4. Let's say we thought maybe it's an 8. So if your GCF were 8, then if 8 goes into 96 and you jump another 8, you would land on 104, so you would miss it. So the trick is you're going to guess a number and your starting point is the difference. So the maximum number is 4. Now 4 happens to work, so you're done. But if 4 didn't work, we would then try its highest divisor. So we would try 2, then we go to 1. So as an example, let's say we're going to 97 and 101. Now this difference again is 4, but then you try 4 and 4 doesn't go into these numbers. So then we try 2. 2 doesn't go into these numbers, so it's 1. So these numbers are what's known as relatively prime, which means they have no divisors other than 1 in common. Let's try 98 and 102. We try 4 because that's their difference, and it doesn't work. We try 2, and it works, so we're done. Now let's try this on a slightly larger problem. So 970 and 1010. So this difference is 40, so we try 40. 40 doesn't go into these numbers. The highest number that goes into 40 next is 20, and 20 still doesn't go into them, so we go to 10. 10 goes into them, so we're done. So when should you use this trick? Usually when the numbers are very close, then it saves you time. So these numbers are large, they're kind of ugly, but they're pretty close, so there's no need to break them down and run your basic method. Now for the LCM, you could sort of do this trick as well, and here's how it would work. if you wanted the LCM of 5 and 6, they have nothing in common. They're relatively prime, so you would just multiply them. And your LCM would be 30. But if you tried that on 6 and 8, 48 is not the least common multiple. The least common multiple is 24. So the general method is you multiply these two numbers, whatever they are, and divide by their GCF. Because the GCF of 6 and 8 is 2, 48 over 2 does give you 24. So let's say you want to try this on 8 and 10. So if you multiply them, you get 80. Their greatest common factor is 2. So 80 over 2 is 40. So the LCM of these numbers would be 40. So that's the trick. I think for most of your needs, you're going to just stick with the basics, but you should be aware of this trick. All right, see you guys in the next video.